Hello. So for this video, we are going to go over fluid structures, and then at the end of this, we are going to go over whether these molecules are either polar covalent or non-polar covalent. Keep in mind that I will be providing sections or providing links for these different sections, so you can actually just skip ahead if you don't want to watch the instructions or the tutorial. Then just skip ahead to the answers. All right. So let's go ahead and start off with hydrogen. So in this case, we are looking at hydrogen here. We do notice that it has one valence electron. So I do put down two hydrogens. And since it has one valence electron, as seen here, then I only put one electron. Those are my two dots, one electron each. And then I just combine, and then I form my bond. That is it. So I'm only going to do this entire column. And you can skip ahead and check the answers. You can check these answers with your teacher. Same thing on this side. So this will be a bit lengthy, but once again, skip ahead. So oxygen, I draw two oxygens. I check back to see what column it is in. Once again, we do not care about this area here. So this is column 13. It's really 3, 4, 5, 6. And notice this value here, this is how many outer electrons oxygen has. So I put 6 dots. 1, 2, 3, 4, 5, 6. And then for the other oxygen, same thing. 1, 2, 3, 4, 5, 6. Then I just link up my single electrons, but for now let's circle our lone pairs just to make sure we do not bond with anything. So here's one bond, single to single, and then another single to another single. These two lines represent a bond, so now I go ahead and draw a double bond between oxygen to oxygen, and then I place the lone pairs. I have to put the lone pairs. All right, now chlorine. We move down right here to this element, chlorine. Notice it's 287. So the two electrons in the first ring, 8 in the second, and in the third ring, the valence ring, has 7 valence electrons. So I need to draw 7 dots. So I draw Cl, another Cl because of this 2 here. And now I go ahead and place my dots. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Notice I have several lone pairs which do not bond. And now I combine my single electron with my other single electron. And then we redraw for clarity. Notice my single bond to chlorine. And then finally, these dots need to be represented in the final drawing. So I place the 3 pairs. Notice 1, 2, 3 pairs. One pair, second pair, third pair. 1, 2, 3 pairs. 1, 2, 3, 4. Or 1, 2, and the third pair. All right. So notice the difference. We ended up with a double bond up here with oxygen, and down here we ended up with a single bond with chlorine. But we represent the lone pairs at the end. Let's try BH3. So boron is right here on column 13. So it will have a valence shell of 3. So notice there it is, the valence shell of 3. And I'm using ptable.com. So I draw boron, 1, 2, 3, all single electrons, hydrogen, and if we recall, it only has one valence electron. So I go ahead and draw 1, 2, and 3. Each hydrogen gets its own valence electron. So now I connect. Boron will be in the center. And then we redraw. So it'll be hydrogen, hydrogen, and hydrogen. And that's it. All right, now let's try PF3. All right, so phosphorus has a valence shell of 5. So let's go ahead and do that. So we have 1, 2, 3, 4, 5. Fluorine now, similar to chlorine, same group, it now has a valence shell of 7. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm going to circle my pairs, that way I don't get too confused. Each fluorine has 3 pairs, and then phosphorus has 1 pair. Remember, we need those pairs in the final drawings. Okay, so let's connect our single electrons. Since phosphorus has the most single electrons, we'll make that the center. Fluorine goes to phosphorus, and the other fluorine goes to phosphorus. All right, so now we have 3 single bonds. So let's go ahead and redraw that. So it's phosphorus with its lone pair, with fluorine, fluorine, and fluorine. This is still an incorrect answer. We need to place the lone pairs. There we go. All right. And keep in mind, we are creating all these bonds to complete the valence or the octet for each element. Some elements require a duet, others a sextet, like boron up here. But in this case, notice we have 1, 2 electrons for phosphorus, and each shared bond or each bond has a shared pair of electrons. So it's 2, 4, 6, 8. And that completes the octet for phosphorus. And over here it's 2, 4, 6, 8 to complete the octet for fluorine. All right, let's try the back side. Okay, so now we have PCl3, phosphorus again with 5 dots, 1, 2, 3, 4, 5. And you can already start seeing where we're going to place these chlorines. Since we have been doing this for so long, you can go ahead and just start drawing them out with where you think they're going to go. And there it is. So my 7 dots for chlorine, I connect, 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 and redraw. So it's going to be phosphorus, chlorine, oops, there we go, chlorine. And there it is. All right, so now this one, in case you're having trouble with it, we have oxygen, nitrogen, and chlorine. So now it is O, N, and Cl. So let's see what's going to go on. So I'm going to draw oxygen. Once again, we already did this before. We have 6 dots for oxygen. So we go 1, 2, 3, 4, 5, 6. Nitrogen, on the other hand, is in group 15. So it has 5 valence electrons. So 1, 2, 3, 4, 5. Chlorine, once again, we did it up here. 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. Let's go ahead and circle our lone pairs that will not bond. All right. So now we find the element that has the most single dots, and it turns out to be nitrogen. So then in that case, we go ahead and bond everything to nitrogen. So I'm going to start with this chlorine, single to single, 1 single oxygen to another single nitrogen, and then our last single dot here. Notice all our lone pairs are circled off, they don't bond, and all of our single dots or single electrons have now bonded. So let's redraw this. We have a double bond between oxygen and nitrogen. We have a single bond to chlorine, and there it is. All right, so that concludes the drawing of the Lewis structures. You can try out the rest. Benzene, you can Google it or check this, check the hint that's below, but try it out on your own and see what happens. All right, it is a ring, by the way. This is a ring. Okay, so in this situation, you've already seen all the answers, but let's show them one more time. Here's the answers to the back side, the answers to the front, and then more answers down here. All right. So at this point, we are going to go into polarity. So for polarity, so we just went over this in class. We're trying to see if we have a polar or a non-polar covalent bond. So we'll see polar or non-polar. Okay. So typically in a polar bond, the molecule is asymmetrical. And then in a nonpolar bond, the molecule is symmetrical. So in other words, you can pretend that there's a tug of war and each hydrogen wants to pull on the other hydrogen's electrons, but since they are the same element, there is no actual net pull. So in this case, this molecule will be nonpolar because it is the same. Oxygen, once again, a tug of war. Even though it has its electrons out here, its lone pairs, it's a tug of war. It is also nonpolar. Chlorine, take a guess. Same thing, nonpolar. Now we have these two molecules right here. Okay, we have three elements bonded to the center element, but in this case, this one here will be nonpolar because we have no net pull in any direction. Okay, so it is a symmetrical molecule. We cut it this way, cut it this way. It's the same thing. All right. Now, keep in mind for these molecules, what we're trying to do, well, we'll go over it later. But in this case, we do have phosphorus down here. Notice how it is not symmetrical. It is symmetrical. We cut it this way. The top and the bottom is the same, but the left and the right is not the same, and there will be a net pull for this phosphorus. So since it is asymmetrical, it is polar. All right. We're going to get into more detail later with some calculations, very basic calculations to determine the pull. But for now, we're just going off of symmetry. Here we have another phosphorus with 3 chlorines, or phosphorus trichloride. So in this case, we are having a net pull. So it is not symmetrical. We cut it in half. The top and the bottom is symmetrical, but the left side and the right side are not. So this will be polar. And this molecule down here, considering that it is not the same, it is definitely polar. Remember, we're looking for symmetry if we cut the molecule in half in any direction. Go ahead and try out the other items out. This pretty much sums up this activity. Here are the answers again. This one's polar, polar, nonpolar, 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 and then finally polar. Try out the rest and check with your teacher.